Okay, so we're going to do semester 2, geometry semester 2 review. And this will be part 1. I can't do it all in one. I might do hour-and-a-half increments. See if I can get it done in two of them in 3 hours for the whole second semester here. Let's see if we can do it. Obviously, I'm not going to be able to cover many specifics. I'm just going to hit the general, some examples of each type. So you have the idea. All right, I'm going to start with special right triangles in case you didn't get to it at the end of first semester. So I have it on the first semester review, but I'm going to start with it here. So those who are just watching the second semester review and you're having to start here, you can see this right away as well. So you have two special right triangles, 30, 60, 90, and 45, 45, 90. Okay, now what makes them special? The reason they're special is because normally, when we just got done doing Pythagorean theorem, and in Pythagorean theorem, you have to know 2 of the 3 sides in your right triangle. So this deals with right triangles again. You have to know 2 of the 3 sides, and you can use Pythagorean theorem to get a third side. Well, so what makes this special is I only have to know 1 of the 3 sides. I can get the other 2 sides. That's what makes this special. Okay, so the relationship on the side lengths, A root 3, and 2A. There is no difference between using the letter A and using the letter X. Those are the exact same thing. Okay, so over here it would be X root 2. So what this is saying is if I know the 30-degree side, the 60-degree length is root 3 times longer. So I just get the root 3 with it along with that A, or the 30-degree side length. And the hypotenuse is double the 30-degree side length every time. It's always the same ratio. On the 45, 45, 90, obviously the 45 and 45 are this exact same length. By the way, this is called an isosceles right triangle. You need to know that vocab-wise. So on the DCAS or SATs, if they say isosceles right triangle, you know exactly what kind of triangle to draw, 45, 45, 90. All right, so let's go ahead and look at examples here. 30, 60, 90. Now let's say we'll start with giving us the 30-degree side. Remember, the 30-degree side is across from the 30-degree angle. So that is the 30-degree side. This is the 60-degree side. And this is the hypotenuse, the 90-degree side. Okay. All right, so remember, identify the hypotenuse first. It's always across. The other 2 sides are called legs. I call this A, B, C. AC and BC are legs. AB is the hypotenuse. You'll learn this in middle school, but quick review, vocab. Okay, so let's go ahead and say that they start with, give me 20 for the hypotenuse. Well, I look over here, that's the 90-degree side. What does it tell me to set the 90-degree side equal to? 2A. So 2A equals 20, therefore A equals 10. What is A? A is the 30-degree side. Where's the 30-degree side? Right here, across from the 30-degree angle. The 60-degree side tells me it's 10 root 3. Root 3 times longer. And there's my answers, filling it in. So I was starting with the hypotenuse given. Okay, now let's go ahead and do one where they start with the 30-degree side given. Let's say this is 4. Then I know that's a 30-degree side. Then I know the 60-degree side is 4 root 3. Root 3 times longer, and the hypotenuse is double that, 8. Okay, now let's say they start with the 60-degree side, the hardest one. And they tell me this is 9. Okay, well, what does it tell me to set the 60-degree side equal to? Right there, a root 3. So 9 equals a root 3. I need to solve for a, so I need to divide by root 3. Divide by root 3. So not a equals 9 over root 3, but I can't have an irrational number in the denominator. Remember, an irrational number is a number that cannot be written as a fraction. A rational number can be written as a fraction. So we do what's called rationalize the denominator. So I'm changing root 3, which is irrational, to a rational number. And the way you do it, you multiply it by the same radical. So now I multiply across, I get 9 root 3 over 3. You got to remember from algebra 1, root 3 times root 3 is 3. We've already gone over this earlier when we did our radicals. This is not simplified all the way. 9 divided by 3 cancels 3 times, so it's 3 root 3. That's what a equals. So I would put that on the a side. On the third degree side, 3 root 3. And then lastly, I take that third degree side and double it. So 3 times 2 is 6 root 3 for the hypotenuse. So I just filled in those other two sides right there. Okay. Now a shortcut to remember, if I'm given the 60-degree side, so I'm dividing by root 3, is I can, if I look at it, I start with 9, and the answer was 3 root 3. So what could I do? I could divide the 9 by 3 and add on that root 3. Okay, so that's a shortcut. From starting with the 60-degree side, I can take that number, whatever it is, divide by root 3, divide by 3, and then multiply by root 3 afterwards, and that's my answer for the third degree side. And then I double that. Okay, all right, 45, 45, 90. I need to go ahead and move down here. Only two options. I'm either given the 45-degree side or the hypotenuse. That's it. So if I'm given the 45-degree side for this isosceles right triangle, they tell me this is 2 root 6. Well, I know the hypotenuse is root 2 times longer. So root 6, 2 root 6 times root 2. And this obviously still is 2 root 6. That would equal 2 root 12. But I cannot leave it as 2 root 12 because that simplifies, because that breaks down to root 4 times root 3. And the root 4 is 2. So I get 2 times 2 is 4. Root 3 does not break down anymore. And so the answer is 4 root 3. Multiplying radicals together. Okay. If you didn't want to go up to 12, remember I showed you that shortcut. Root 6 times root 2. What's the GCF? 2. So I can do this as 3 times 2 for that 6, and I still have the root 2 there. Root 2 times root 2 is 2. And so that equals 2 root 3. And then I have the 2 out front. I'm still multiplying by to get the 4 root 3 for my final answer. That's another way of multiplying your radicals. It's no big deal with that small of a number. I just reminded you, if you dealt with larger numbers, that you can do that. All right, the other way is if they give me the hypotenuse. Let's say I start with 8. Okay, well, what does it say to set the hypotenuse equal to? A root 2. So a root 2 equals 8. Divide by root 2. Divide by root 2. Can't have radical in denominator, so I must rationalize the denominator. Multiply by root 2 over root 2 to get rid of that radical. I get 8 root 2 over 2, and that simplifies down to 4 root 2. And so both of these are 4 root 2, since they're isosceles. Okay, now there's a shortcut for this one too. How do I get from 8 down to 4? I divide by 2. So divide by 2 and add on that root 2. That's your shortcut. Okay, so there's special right triangles. All right, next concept we go to is SOHCAHTOA. Trig. We're just doing the basics of trig, trigonometry. Okay, and we have SOHCAHTOA. Okay, each one of these stands for a specific trig function. The capital S stands for sine, which in a calculator gives you the first three letters. So sine equals, as it says here, O over H. O stands for opposite, the opposite side, and H for the hypotenuse. C stands for cosine. On your calculator, cos, C-O-S, first three letters. A stands for adjacent, which means next to, as you learned in the first semester, hypotenuse across from the right angle. And T stands for tangent. And that is TAN on your calculator. And that is O for opposite over adjacent side next to. Okay. Now each of these has a reciprocal. Reciprocal, remember, you switch the numerator and the denominator. The reciprocal of sine is, so now we do reciprocals. I'll say reciprocal, reciprocal, reciprocal. Is cosecant. That's the three letters it uses, which you can't get off your calculator, is CSC. And that's the reciprocal. So that's going to be the hypotenuse over the opposite. The reciprocal of cosine is secant. And those three letters are SEC. Reciprocal would be hypotenuse over adjacent. And the reciprocal of tangent is cotangent. For the three letters for that is COT, and that would be adjacent over opposite. Okay. So again, if the answer was 3/5 for sine, it'd be 5/3 for cosecant. If cosine was 4/5, it'd be 5/4 for secant. If tangent was 2/7, then cotangent would be 7/2, the reciprocal. Okay. So now let's go ahead and look at some examples. Again, this is in right triangles only. Again, why we have it right after our special right triangles and after Pythagorean theorem. All these deal with right triangles. Okay, so let's say I have a right triangle and it tells me this is 8 and this is 17. A, B, C. And it tells me to find the sixth find the six trigonometric ratios. Okay, well, what is a ratio? A ratio is a fraction. Okay, so I better have six fractions. That's my answer. Okay, well, first off, I have to go ahead and find the third side length here. And if you have your Pythagorean triples memorized, you know it's an 8, 15, 17 Pythagorean triple. I don't have to do any work. Otherwise, you have to use Pythagorean theorem to go ahead and do that. And I'm not going to do that. Pythagorean theorem was in the first semester and in middle school. Okay, so my six trigs, sine, and reciprocal of that is cosecant. Cosine, let's make some more room here. Cosine and secant. Tangent and cotangent. Okay, and we're going to do it from all from angle A. Okay. Let me make sure I've got it. Let's go. Okay. All from angle A. So I could have put in A right there. A. Oops. So this little piece come over. Nope. A. A. A, and A. I'm going to squeeze that in there. Okay, so that means theta is angle A. First thing I need to do with all my right triangles is identify the hypotenuse first. Then I go ahead, there's my theta, so right next to it, the word for next to means adjacent. So there's my A, and there's my O, opposite. So I know which one to use. Okay, so the sine is opposite. Let me go ahead and write down SOHCAHTOA again. So sine, as we hear, is opposite over hypotenuse. O over H, which is 15 over 17. So the reciprocal of that would be 17 over 15 for cosecant. The cosine right here is adjacent over hypotenuse. So A over H, 8 over 17, and reciprocal 17 over 8. The tangent is opposite over adjacent over A, so 15 over 8, and the reciprocal 8 over 15. Now, if any of these fractions reduce, I would reduce them, but they don't, so there they are. So if it says to find the 6 trigonometric ratios, this is what it's asking for. Whenever you see a ratio, you write it as a fraction. Okay. Now, so that's one type of question it could ask. Okay. Next is it could ask for a side length. It gives you an angle measure and one side length and asks you to find one of the others. So say this tells me this is 35 degrees, and they tell me this is 12. Find that side length. Okay. I'll first identify what each piece is. Okay. And I'm using this angle right here. That's why it's adjacent for A for the 12 and O. Okay. So which of the two pieces I'm going to use? I'm using the X and the 12. That's the O and the A. Well, O and A is tangent. So I have tangent of 35 equals O over A, X over 12. Put this over 1, cross multiply. X equals 12 tangent 35. Okay, notice I put the 12 up front, put the trig function last. That way it doesn't mess up in your calculator. If you did tangent 35 times 12, it would actually do 35 times 12 first, get that answer, and then multiply, and then find the tangent of it. We do not want to do that. So put the number by itself in front and the trig function last. That's the exact answer. It's going to ask you to go ahead and do it to like the nearest tenth. So we're going to pull out the graphing calculator. Let's start. Oops, come on now. Start. Okay, here's my graphing calculator. By default, the calculator's mode is radians. So I hit the mode button, go down to radians, change it to degrees, hit enter, so I can quit. And let me go back to what my question was. 12 tangent 35. So type in 12 tangent 35. And the answer is 8.4. We're going to go ahead and round to the nearest tenth. 8.4. Okay. Let's say we'll do one more. Let's say this is 70 degrees. This is 10, and they want you to find the hypotenuse. It's called R. So again, I identify my pieces. Hypotenuse is always hypotenuse, never changes. Next to the 70 is the 10. Next to me is adjacent, and across from is opposite. Okay, so I'm using the A here and the H. SOHCAHTOA, A and H, is cosine. So I have cosine of 70 equals A, which is 10, over H, which is the R. Put it over 1, cross multiply. R cosine 70 equals 10. Cosine 70 is a number, just like a coefficient, so I go ahead and divide by cosine 70 on both sides. That's the exact answer, but we're going to do the nearest tenth. So I go 10 divided by cosine 70. 10 divided by cosine 70. And I get 29.2. So there's the length of the hypotenuse, 29.2. Okay. And that's how you do that. So now that's finding side lengths. So when I'm doing side lengths, I'm just using the SOHCAHTOA. I'm not using the inverse yet. One thing to know, if that's 70 degrees, this is 20 degrees, it's called the complement. Remember, those are complementary angles. Since I've already used 90 up in a triangle, 180 minus 90 is 90 left. So these two angles must add to 90. That's the definition of complementary. Also, to go along with that, let's go ahead and look at this real quick. If I call this A, B, C, okay, and I call this theta up here. Then when I go ahead and name things, there's my H, there's my adjacent next to, and there's my opposite. So if I do sine of theta, that'd be the opposite, which is segment or length BC over the hypotenuse AB. Okay. Well, what is, because I don't have numbers, I have to just use the length of the side itself. What's another angle, another trig function that will also give me BC over AB? Well, if I use this angle right here, first off, what is that angle going to be? Since these two are complementary, that has to be 90 minus theta. So that's going to be 90 minus theta. So 90 minus theta. What trig function? And now if I use that as my angle, then this one becomes the adjacent, and this one becomes the opposite. And which one is going to give me the answer of, I want the same answer, BC over AB. Where's BC here? BC is the A, and AB is the H. So what is A over H? That's cosine. So the cosine of 90 minus theta equals BC over AB. So what we need to learn is the sine of one of the acute angles equals the cosine of the other acute angle. That's one thing to notice right here. Okay, this kind of stuff is on the DCAS. Okay, so they might have theta and 90 minus theta. They might have x or 90 in, or if there's x over here, it'd be 90 minus x. Okay, it could have in numbers. Okay, it could add a 40 and a 50 in there. There'd be sine of 40 equals the cosine of 50. So if you wanted to see that, so that's 40 and that's 50. So we're saying the sine of 40 equals the cosine of 50. If you want to see that, you just plug in your calculator. Sine of 40, enter. Cosine of 50, enter. Exact same answer. Okay, so we can see that's true. Okay, and that's what that is saying right above. So these are different ways of showing the same thing. Okay, that kind of problem is on the DCAS, just so you know. Every year it's been on it. So 40 and 50, remember, are called complements because they are complementary. They add 90 degrees. Those are complements. Complements with an E, not an I. Complements. 40 plus 50 is 90. All right, so the other type dealing with the trig is if I want to find an angle measure now. F, G, H, and let's say I want to find this angle measure, and they give me this length is 20 and this length is 13. Okay. So again, the very first thing I do is identify my three pieces. Hypotenuse first, then my adjacent side, which is right next to the theta, and my opposite side across from it. So which two have the numbers on it? The O and the H. Again, I look at SOHCAHTOA. Where is the O and the H? Right there. So it tells you I'm going to use sine. The sine of theta, right next to the trig function, sine, cosine, or tangent is always the angle measure. This is always angle measure. So the sine of theta equals the opposite, 13 over 20, the hypotenuse. Remember, I'm solving for theta, so I got to get rid of sine. How do I get rid of sine? I get rid of sine by doing inverse sine. They cancel each other out. Whatever I do to one side, I must do to the other side. So those cancel out, and I get theta equals inverse sine of 13/20. So now I can go ahead and type that in the calculator. That's the exact answer. I'm going to do an approximate answer. We'll go to the nearest degree. They often ask the nearest degree. Inverse, second sine is inverse sine of 13 divided by 20. And I get 40.5 degrees, so that's going to round up to 41 degrees. So 41 degrees would be my answer for theta, going to the nearest degree. Okay, nearest degree. All right, those are the main things that we dealt with in SOHCAHTOA. Okay, either find a side length or an angle measure. Okay, so now let's go ahead and we're going to jump to mod 5. Mod 5 is our circles. Okay. You hear that noise? I've got worksheets here and tests, assignments, all this that I'm looking at to come up with example problems covering all these. So mod 5 is circles. So we did stuff in circles in first semester. We have in the past years. I'm assuming I'm still doing it. Instead of waiting all the way till second semester to deal with only circles, I brought in a few concepts in the beginning. I'm still going to repeat that, just like we started over from scratch in second semester in mod 5. So we talked about, first off, we dealt with equations. Okay, circle, standard equation of a circle. X minus h quantity squared plus y minus k quantity squared equals r squared, where h comma k equals the center and r equals the radius. Okay, so if that gave me an example, x minus 2 squared plus y minus or plus 1 squared equals 4. And they say, what is the center and the radius? Okay, the 3 words that you should have memorized that go along with it. This is opposite, opposite, because another word for subtraction is opposite, and this is square root. Why square root? Because that says r squared, and we want r, so you have to go down to get down to r. Rows 1 is take the square root. So you could write it down here again, opposite, opposite, square root. So that's going to be 2 comma negative 1 is my center, and the radius equals 2. The square root of 4 is 2. Now I might say to graph it. So if I graph it, 2, negative 1 is my center, and I'm going to go out 2 in each direction, north, east, south, and west. So 2 north puts it there, 2 east, 2 south, and 2 west. And then I just do my best to draw a circle going through all those 4 points. And that'd be the graph of the circle. Now they might also start with this circle itself. And so I identify that circle as 2, negative 1, the center, and the radius. I count out to one of the points. I see the radius is 2. And then I go backwards to come up with this equation. Remember, I'm always doing the opposite. So the opposite of 2 is negative 2. That's why I see x minus 2 is quantity squared. The opposite of minus 1 is plus 1. That's why you see the plus 1 here. And then on the right side, remember, this is r squared. Well, r is 2, so I have to square that number and get 4. So I'm going backwards. Okay. Next type, dealing with that, and we'll throw in the midpoint formula to apply it to it, is given endpoints of diameter. Endpoints of diameter. And we say that is 2, negative 4, and we'll say it's 4, negative 2. Now let's go negative 4, negative 2. Okay. So those are the endpoints of diameter. So remember, a circle, that's the diameter. So here's my endpoints. So how do I get to the center? I got to take the midpoint. So that's the midpoint formula. Midpoint formula, go ahead and write down here. It's just the average of the x's. So x sub 1 plus x sub 2 divided by 2, comma, y sub 1 plus y sub 2 divided by 2. Okay, so I add my x's together. 2 plus negative 4 divided by 2 and negative 4 plus negative 2 divided by 2. 2 minus 4 is negative 2 divided by 2 is negative 1, and negative 4 minus 2 is negative 6 divided by 2 is negative 3. So my center is negative 1, negative 3. Okay, now how do I get the radius? Definition of radius is center to point on circle. So I have the center now, negative 1, negative 3, and I have 2 points on the circle, 2, negative 4, negative 4, 2. It's my choice which one I want to find the distance from, or 2. Okay. So remember, the left side of the equation is the center. This right here, that's the center. So I already have that, so I can fill in the left side right now. This is the radius on the right side that I have to calculate first. Okay, so I'm going to fill it in. Remember, it's opposite, square root. So it's x plus 1, because the opposite of negative 1 is plus 1, quantity squared. Opposite of minus 3 is plus 3, quantity squared. And now I need to fill in whatever r squared is. I need to find r squared. Okay, so my center was negative 1, 3. Negative 1, negative 3, I meant. Negative 1, negative 3. And one of the points, 2, negative 4, or negative 4, negative 2. We'll go negative 4, negative 2 right there. Okay, so I need to find that distance. Oh, I just said the word distance. That means distance formula is one way I could use it. X sub 2 to find it. X sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Okay, so if I was using distance formula, I don't even have to plot the points. I'm plotting it because next I'm going to do Pythagorean theorem, because we're going to remember that distance formula is the same thing as Pythagorean theorem. So the sub 2 and the sub 1 just mean 0.1 and 0.2. It doesn't matter which one I call 0.1 and 0.2. So I'll just call this 0.1 and this one 0.2. It does not matter. I could have switched that. I'll still get the same answer. So plugging that in, 0.2, it'll be negative 1 minus negative 4 squared plus y sub 2, negative 3 minus negative 2, quantity squared. So if you're doing this, you can see you need to know your integers well. You're supposed to have those mastered from middle school. So that makes that a plus, that makes that a plus. So I get 4 minus 1 is 3 squared is 9, and negative 3 plus 2, or the same thing as 2 minus 3 is negative 1 squared, which is 1. So now I have d equaling the square root of 10. Okay. Now, another an advantage of doing Pythagorean theorem is I can visually count instead. I'm going right 3 and down 1, so this is 1. And I have Pythagorean theorem, which we know is a squared plus b squared equals c squared, with c being the hypotenuse. In this case, the radius is the hypotenuse, because there's my right angle. Remember, the hypotenuse is always across from the right angle. So a squared would be 9 plus b squared 1 equals r squared. And 9 plus 1 is 10. Remember, I'm solving for r squared. That's what I need to fill in. Right here, r squared. Well, there it is. R squared equals 10. And there it is right there. So that's an advantage of using Pythagorean theorem. Here, this is really r. D is the same thing as r, the radius. But notice I'm not doing r that I'm putting into here. I got to do r squared, so I have to square that radical, and that takes off the radical, and then that gives me the 10. So the one thing, disadvantage of using distance formula, you can mess up with integers, and you have to remember to square your answer in the end. If I use Pythagorean theorem, I don't have to do it at all. I have a squared plus b squared equals c squared, which is the c is the r. And so I'm already have my r squared right there and plug it right into 10. I don't have to remember to do anything else. Okay, so that was applying the midpoint formula to an equation of a circle. Okay, what else do we have with that? We need to complete the square now to identify the center and the radius. So complete square to find center and radius of circle. Okay, they give you this equation, say x squared plus y squared equals 6 plus 4x minus 8y. Okay, so the first thing I need to do is get my x's and y's to one side and my constant to the other. So how do you decide which side? I need my x squared, my y squared, those coefficients to be positive. They already are positive. That means I'm moving it to the left side. So that's already there. I need to move the 4x, positive 4x across. That becomes negative 4x. Then I'm going to put a plus blank. And then I have my y squared. I need to move the y coordinate, the y term across. That makes it plus 8y. And put a plus blank. Equals my constant's already on the right side, so it stays there, plus blank. And you ask what are these plus blanks for? Because we need to complete the square. And since whatever number I put in here is not already here in the equation, so we're going to add two numbers on the left side. I'm going to add those together and add it to the right side to keep the equation the same. If I add something to one side, I must add it to the other side. So the question is, how do I know what number goes in there to complete the square? It is always 1/2 of b quantity squared. 1/2 of b quantity squared. So now you ask, where's b? I don't see a b in here. Well, you have to remember the standard form of a quadratic, ax squared plus bx plus c. So the b is the coefficient of the linear term. There's my linear term. Linear term has a degree of 1 on it. Remember, this is called the quadratic term. It's degree 2. I'll say quad term. Linear term. And this would be the constant term because it's just a number. Remember, a number by itself is called a constant. That's C. So 1/2 of B, I write it down, -2. Include the sign with it. So 1/2 of -4 is -2. Squared is 4. 1/2 of 8. So if you need to, circle that so you include the sign, as I just did with the positive 8. 1/2 of positive 8 is positive 4. Squared is 16. Do not forget, whenever I square any number, I better get a positive answer. So you better not have any negatives in those right there. So 4 plus 16 is 20. So I have to add 20 to the right side. Let's change this to 8. So we have to do a little more work. Okay, work on reducing our radicals. All right, so now I can write it in standard form because this is a perfect square trinomial. This piece right here and this piece right here is a perfect square trinomial from Algebra 1. Now, of course, I know most of you forget your factoring. Factoring is major in Algebra 1. Your Algebra 1 teacher has told you this. Okay, so I'm just going to show you how you can get it easier and just memorize this. If you wrote this down correctly, the 1/2 of the b with the sign right, you just have to drop it right in there. X minus 2 quantity squared. The same thing here. Y, drop it down in there. Plus 4 quantity squared equals 28. So now that's the standard form of an equation of a circle. Now I need to find the center and the radius. And we know it's opposite square root. So center, therefore, is 2, -4, and the radius equals the square root of 28, but since that simplifies down, I must simplify it. Square root of 4 times square root of 7, and that reduces down to then 2 root 7. If you leave it as square root of 28, you lose a point. On the DCAS, you get no points. You have to have it simplified down to 2 root 7. Okay, I can give you partial credit, 1 out of 2, by leaving a square root of 28, but at DCAS, you would get 0. You have to reduce it down to 2 root 7 or simplify it. Okay, so that's how you complete the square to find the standard form of the equation of a circle, and then take the opposite square root to get the center and the radius. Okay. All right, covered those. All right, next we do inscribed circles. Inscribed angles, I meant, and inscribed quadrilaterals. Inscribed angles and inscribed quadrilaterals. I was going to say quads. Okay, inscribed. In means inside, scribe means write. So you're going to draw or write inside the circle. So here's my center, call it P. That means you call it circle P. It goes by whatever the center of the circle is. An inscribed angle is an angle that is on the circle. So this is my inscribed angle right there. BCD. The intercepted arc is if I draw this out to the circle and just connect it together now. This is called the intercepted arc. Intercepted arc is arc BD. Okay. Let's say this was 210 degrees. Then the inscribed angle is always half of it. So it'd be 105. So inscribed angle, that's the angle measure, angle symbol meant, equals 1/2 of intercepted arc. INT for intercepted. Okay, so that's the rule. One to remember that they always throw in there, if I draw a triangle like this, remember this, we call it angle B, and they say, what's the measure of angle B? And you say, look, they have no numbers on there. They have enough information for you to find that out. No problem without any numbers on there, because I should recognize that's a diameter. So the arc is half of the entire circle, and half of 360 is 180 now, and half of 180 is 90 degrees. Do not forget that. If this is angle A and this is angle C, what do I know that angle BAC, this angle, what's called X, and this angle Y, what do they have to add to? If that's already 90 degrees of my triangle, then the other two have to add to 90, so X plus Y equals 90 degrees, or angle BAC plus angle BCA is 90 degrees. Don't forget it. All right, inscribed quadrilaterals. Okay, draw a circle. Inscribed again, they have to be inscribed angles. Okay, so there's an inscribed quadrilateral right there. And the rule is opposite angles are supplementary. And you should know from semester 1 that supplementary means two angles that add to 180. Not that equal 180, that add to 180. So if this is 70 degrees, this is 110 degrees. If this is 2x plus 5, and this is 3x plus 15, and I know those two add to 180, so I'm going to just combine like terms now, and I have 5x plus 20 equals 180. Subtract the 20 across, and I get 160, and divide by 5 on both sides, and I get 32. So x is 32. And then if it asks for the angle measure, you'd plug it back in. 2 times 32 is 64 plus 5 is 69 degrees. Then I could just subtract from 180 to get the other one. 180 minus 160 or 180 minus 69 is 111. Those two add to 180 now. So inscribed quadrilaterals, the opposite angles are supplementary. Okay, so that's inscribed angles. Okay, so now let's go to tangents and secants. Okay. Next page. Tangents and secants. So a tangent is a segment that only touches the circle in one spot. If I connect it and connect that segment all the way through to make it a line like or a ray, it's only going to touch in one spot. Tangent only touches circle in one point, even if extended. So for example, that is not a tangent. Just because it touches at one point, that's not a tangent. Because if I extend that, that would hit twice. And that's a secant. Secant touches circle twice. Okay. So that's what a tangent is this one's the tangent, and this one is the secant. Okay. So that's definitions to know. All right. So tangent is also 90 degrees to the center of the circle. Tangent. Perpendicular to center of circle. Okay, so I automatically put the right angle symbol in there anytime I see and they tell me it's a tangent. Okay, so just know that. All right, now let's go ahead and look at some problems. I want to find lengths of things. So there's a tangent, call it P, call this O. There's a secant, call this R, call this S, call this T. Okay, let's say they say this is 8, this piece is 4, this piece in here is 12. Okay, anytime I have a tangent, I square it. Tangents, tangent length, square it. Secant length, outside length times whole length. Okay, take off my jacket here. All right, so here we go. There's a tangent, so I square it. Okay, and for secant, I do outside, which is 4, that piece, times the whole, which is 4 plus 12. 4 plus 12, not 4 times 12. 4 plus 12 is the whole. So that's the outside. This is the whole. So I get 64. Oh, wow. I can't believe I actually, that's not a problem. We wouldn't even be doing that part. I'd have to fill in one of these 4 times 16. That actually happens to be 64. I can't believe that. Okay, thrown in there. That just tells me those are true. Okay, but you're going to be given one of these missing. Okay, so let's do it again. I got to have one of those pieces missing for you. Okay, so tangent, secant, okay, so let's just say we don't know what that is, but we know this is 4 and this is 20. Okay, so my equation I'd set up would be x squared, because it's a tangent, so I know to square that, equals the outside 4 times the whole, 20 plus 4. So I have x squared equals 4 times 24. Now I could sit there and multiply that together, or as we learned before, dealing with radicals and geometric means first semester, just take the square root of each one. So x equals 2 for that one. That's a perfect square. And square root of 24 breaks down to 2 root 6. And so final answer is 4 root 6. X equals 4 root 6. That's the exact answer. Now, if they wanted you to round to the nearest tenth, you just put that in the calculator, round to the nearest tenth. Okay, so there's one type. If I went ahead and gave you the tangent to begin with, let's say that's 10, and I don't know what that one is, and I call this one 5. Okay, the secant. Well, then I have 10. Let's change the color. I have 10 squared for the tangent. I'm always squaring the tangent, equals the outside times the whole. Now what's the whole? 5 plus x. The whole length is 5 plus x. So now I have 100 equals 5 times the quantity 5 plus x. I don't need to distribute. I can divide by 5 right away to be smarter. So I get 5 plus x equals 20. 5 plus what equals 20? X equals 15. Okay? And that'd be my answer. So anytime you're dealing with an equation that has a tangent, you square it. Anytime it's a secant, it's the outside times the whole length. And for the whole, you must add the outside plus the inside. Don't forget it. Okay, so that's dealing with tangents. Let's see. I could also have 2 secants. We're talking about angle measures now. Call it P, R, S, T, U. Call it circle Z. Okay, if I want to find this angle measure, let's call it X right there. We'll change the color so it stands out. Trying to find that angle measure. How to find that angle measure? It's the outside. Now let's change the color. Or the big circle. Big, not circle, big arc minus the little arc or small arc. Big arc minus little arc equals double the angle. Double the angle. Okay, so if I'm solving for x, I have to be given the big arc. Let's say it's 225, and this is 105 right there. Let's just say that. Okay, that would mean I go big arc, 225, minus little arc, 105, equals double the angle, 2x. So now I have 120 equals 2x. Divide by 2, I get x equals 60. So that's 60 degrees then, okay, if those numbers were correct. Okay, doesn't matter if it looks like it or not, we have to go by what's given to us. Okay, so to find the angle measure, big arc minus little arc equals that. Now, they could sit there and give us the angle measure. And one of the arcs, and you have to find the other one. Say they tell me this is 40 degrees. If we don't know what that one is, and they tell me this one is 200 degrees. Okay, well, it's the same formula. Big arc minus little arc equals double the angle. Double 40 is 80. I want to solve for x. I'd be smart, add it across. Which means now I subtract that across. 200 minus 80 is 120 degrees. So then this right here would be 120 degrees. Okay, they could have made the 200 the x and gave me the smaller arc. I'd do the same formula and solve it for it. All right. Another type. Let's say I have two tangents. Two tangents from the same point are always congruent. So if they told me this was 8, this has to be 8. Okay, remember they're both also 90 degrees to the center of the circle because they're a tangent. Okay, so then don't forget these are radii. So now we have a kite there is what it actually creates, right? From first semester. That's a kite. Two pairs of consecutive sides being congruent. There's a kite there. Okay, so if they told me this angle was 60, well, now I have a 90 to 90 is 180 plus 60 is 240 from 360 because it's a quadrilateral, right? So 360 minus 240 gives me 120 degrees. So that means that's 120 degrees right there. Okay, so there's another type you need to know how to do. If I had a circle and I had tangents, those are all tangents. And they tell me this is 3, this is 2, and this is 5. It says find the perimeter of triangle ABC. Well, I should know, since I just said it, that these are tangents from the same point. So that makes this 3, this makes this 5, and this makes this 2 now. And now I can add up the sides and have the perimeter. 5 plus 7 is 12, plus 8 is 20, equals the perimeter. Okay? So you need to know that. Okay, other things with circles. If I have two chords, this is a chord, okay, is a segment connecting 2 points on the circle. Okay, that's a chord. A, B, C, D are 2 chords. A, B is 1 chord, C, D is the other chord. Okay. Now, what can I say about these? First off, where do you think the longest chord is? Not of these two. I'm just saying what's the longest chord in a circle? Longest chord. Let's see if you can get it before I write it. the diameter. Okay, that's the longest chord. So the closer the chord is, it says the diameter is the longest chord. The closer the chord is to the center of the circle, the longer the chord is. The further the chord is away from the circle, the shorter the chord is. If chords are congruent, if those two are congruent, equal length, then the intercepted arcs between them are congruent in length. Okay, I'm just saying it. I'm not writing all that out in words. So if they told me this was 130 degrees, they told me this is 50, and they said solve for x, solve for arc CD. Measure of arc CD equals what? Well, I know I put a 50 in here, and I know the whole circle is 360 degrees. So I have 100 plus 130 is 230. From 360 is 130 degrees. Okay. All right. Other things with chords. If here's the center and here's a chord, if I have a segment, a radius, or a diameter that is perpendicular to the chord, if it's perpendicular, then that guarantees that this is a diameter. Guarantees it's a diameter now. If it is not perpendicular, it guarantees it's not a diameter. That's one thing. Another thing that goes along with that, if it's perpendicular like that, it bisects that chord and bisects those intercepted arcs right there. Okay. Now don't forget any point from any segment from the center to the point on the circle is a radius. So that point right there is also a radius. That segment is also a radius. That segment right there is also a radius. So now I have a right triangle, and they might give me a piece. They might say the radius is a certain number. They might tell me this is 4. And they say the radius equals 5. Well, then I know that's 3 because I have a 3, 4, 5 Pythagorean triple right there. Okay, that's another thing to know about chords. Going back up here, if the chords are congruent, they're also equidistant. Let's change the color. They're also equidistant from the center of the circle. So from that length has to be equal to this length. Or distance is always at 90 degrees. So if two chords are congruent, so you see they're already congruent, then they're equidistant from the center. That's another piece that's true about chords. Okay, if they're not equidistant, then if the chords themselves aren't equidistant, then they aren't equidistant from the center. Because remember, the further away they are from the center, the smaller they are, the larger they are, the closer they are. So in order to be the exact same distance away, they must be congruent. Okay, so that's another thing you can do with that. Okay, I believe that is everything with chords. Within. Okay, now we have, let's go to the next one here. So I can draw it bigger here. If I have two chords like this, A, B, C, D, if I go ahead and multiply each individual piece of the chord, they have to equal the other individual pieces of the other chord together. So if this is 2 and this is 8 and this is 4 and this is X, I know 8 times 2, there's 2 pieces of that chord, have to equal 4 times X, the 2 pieces of the other chord. So I have 16 equals 4X, X equals 4. Okay? So that's another thing with chords. Again, you're going to see that on the test and possibly on the DCAS. They really focus on the DCAS and the circles, guarantee things complete in the square. They give you an equation in standard form, and you have to identify the center and radius, opposite, square root. You have to if they give you an equation in standard form, they'll ask you to graph it. You know, it'll be multiple choice graphs to choose from. Okay, so you got to identify the center of the radius and pick the graph that is graphed correctly. Or they will give you a graph of a circle and you go back and choose the standard form or write the standard form of the equation of the circle. Guaranteed to have those. Guaranteed to have inscribed angles or inscribed quadrilaterals or both. That's why I focus on those throughout the year because those are guaranteed. Guaranteed for sure. Now, how much of the secant stuff? I haven't seen them put a lot of the chord stuff on. They might put this chord one on here, but the other ones talking about the distance, equaling distance away from the center and the chords being congruent, then their intercepted arcs are also congruent. Those are not, I haven't seen those as much on there. Obviously, you're going to get tested on it, but those aren't things to focus on. The ones I'm focusing on are the ones that I've shown with you throughout the year. Inscribed angles, inscribed quadrilaterals, completing the square, graphing the circle, and going backwards. Okay, and you could have a tangent, a secant one. Tangent and secant would be the last, like I had already done before. Okay. Oh, last piece with chords is finding the angle measure of the inside angles. So A, B, C, D. If I want this angle right here, it is the average of the two intercepted arcs. So that arc plus that arc divided by 2 equals that angle and that angle. Okay, so let's say this was 110 degrees, this is 120 degrees. Okay, I add those together, that would be 230 degrees, and divide by 2, and that gives me 115. So both of these would be 115. I don't have to add them together. I can just say what's the midpoint of 110 and 120 is 115. I just do it that way. But I'm showing you if you don't, that would be the official way. Okay, if you don't have common sense to take the midpoint of 110 and 120 and get 115, you can add the two together and divide by 2. Okay, then don't forget, this forms the other two next to it form a linear pair, right? So 115 from 180 is 65 degrees, and these are vertical angles, so they're both 65. So that tells me that whatever arc BA is plus arc CD, they have to add to 130 degrees, double that angle. Okay, which makes sense because I have 230 here, which means I have 130 left to split up between these two arcs, intercepted arcs. They have to add to 130 degrees to make the complete circle. Okay, so that's the other type you could have if they ask you to find the inside angle, inside the circle. This is not the center. This is a point off the center right there. Okay, and to know that, they would have to already had the point there in the center for it to be. So, for example, if I have this right here, oh, so to know, we talked about inscribed angles, half it. This is called a central angle when it actually touches the center. That's called a central angle. The central angle, if this is 80 degrees, that equals the intercepted arc itself, 80 degrees. Remember, we talked about the central angle. If I connected to that, obviously it's the same intercepted arc, so that makes it half of it, 40 degrees. But the central angle equals the intercepted arc itself. That's what I forgot to say when I talk about inscribed angles. Okay, so know that. All right, I believe, let's see. Okay, areas of the, okay. Circumference, capital C, is 2 pi r or pi d. You should know that from middle school. R is the radius, d is diameter. So it says, what's the circumference of that circle? That'd be 2 pi r, or 10 pi units. Okay, if they don't give you the units, if I had inches there, then it'd be inches. Okay, cannot forget units. Okay, that circumference If I want area of the circle, take the area, that's pi r squared. You should know that from middle school. So pi r squared, r is 5 squared, so 25 pi. If it's inches, it's area, it's inches squared. Now, how do you know if it's um, inches squared or inches cubed? I look at the variable in there and look at the degree of the variable. And that can be more than one variable. If there's more than one variable, I got to add all their degrees together. Remember, pi is not a variable. Pi is a number, 3.141529, etc. So that's degree 2. That means I multiplied 2 pieces together, r times r. So that tells me the units must be degree 2. This has only got a d in here, or an r. That's degree 1. So that's why I know it's degree 1 for my units, or pi is not a variable. If I multiplied 3 variables together, then that'd be volume. We're going to talk about that for deal with mod 3. Okay. So those are those basics. Now we're going to talk about, if we talk about a fraction of the circumference. A fraction of the circumference, some degrees, some less than 360, because we know a circle is 360 degrees, of the circumference. We just wrote down the circumference formula is 2 pi r. That means I'm going partly around the circle. So I'm going like this. And they tell me that's 150 degrees. They could put the 150 there, or they could put the 150 degrees up there. Usually they put it right here. And they're wanting what the arc length is. This distance right here is called arc length. So what do you think this formula is called? The arc length formula. It's a fraction of the entire circumference. Circumference right there, 2 pi r. There's my fraction. It's always at 360 because it's 360 degrees in a circle. So now I just take that and plug it right in there. So I have 150 over 360, and say this was 10 times 2 times pi times 10. Well, those cancel out. 15 over 36 divided by 3 each. So that gives me 5/12 times 2 times 10 is 20. Well, I could even cancel down further. So 2 pi 10. 2 cancels this 6 times, but then another 2 goes into 10. Oops. And so I have 5 times 5 times pi is 25 pi over 3. That's the exact answer. So when they talk about exact answer, you leave pi in the answer. If I want an approximate answer, then I put pi in the calculator. Okay, exact pi in answer. You need to know this. Just like with radicals, if I want the exact answer, you leave it in radical form, just simplified. If I want an approximate answer, then you put the radical in your calculator and round to whatever. Okay. Yeah, did I have to do all that canceling? No, I like working on my mental math skills instead of having to use a calculator. I could have sat there and gone 150 times 10 is 1500 times 2 is 3000 pi divided by 360. And then you put 3000 divided by 360. It gives you that decimal, and I hit math, enter, enter, and it gives me the fraction of 25 thirds. I came up with that 25 thirds in my own brain using cross canceling and canceling straight down vertically. So it makes you feel better because I did it on my own without depending on a calculator. I could have sat there and just plugged in the calculator and just did math enter enter and gave me that fraction and 25 pi over 3. So that's arc length. Well, we have the same idea. So arc length deals with the distance around the circle, part of the circumference. So I have the same exact idea with area. Let's say it's 9 degrees. I want the area of that shaded region. It's called a sector. Find area of sector. Okay, well, it's a fraction. We can see it's a fraction of the whole circle. How many degrees are in a whole circle? 360. So there's my x again. And its area, because it's shaded inside. What's the area formula for a circle? Pi r squared. So that's the sector formula. Find the area of the sector. That's what that formula is right there. It's a fraction of the area of the circle. And I see the right angle symbol, so I know how to put a 90 in right there. And let's put in a 6 right there. The radius, 6 squared. So now 90 over 360 cancels down to 1/4 times 36 pi. And what's 36 divided by 4? 9. 9 pi. And notice it's r squared. I did r times r, so that's degree 2, so that's area. So units squared. Okay. So now I believe we've covered everything with circles. So I got to use those formulas. Okay. Dealing with that. I'm going to go ahead and stop right there. Let's do one more because this is one that students struggled with. Clock. Not knowing degrees of a clock. 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And it asks, let's say, arcs. With arcs. A major arc, this is vocab, major arc is greater than 180 and less than 360. Obviously, 180 degrees itself is called a semicircle. Okay, and if it's a minor arc, it's between 0 and 90. Minor arc. So you got to know this vocab because it could say it's 4 o'clock. So you have to know what 4 o'clock looks like. It says find the what did it say to find? Let's see. Okay, find the distance along the edge of the clock from the minute hand to the hour hand, in this case at 4 o'clock, if the diameter is 10 inches. So they give you a diameter 10 inches. And then it says use the minor arc. Okay, so I have to know the minor arc, therefore, is from here to here. That's the minor arc, because that's between 0 and 180 degrees. If they ask to use the major arc, then I'd be finding this distance from here to here. So that's another reason why I have to know the difference between minor and major arcs. Okay, so minor arc, this is major arc. Okay, red, minor arc. And they ask you to find distance along clock of minor arc. Okay, that's what you're trying to find. And they told me the diameter was 10. So what am I finding? Am I finding the area of a sector, or am I finding a fraction of the circumference? Distance around the circle is circumference. So I write down the circumference formula, 2 pi r. I'm doing a fraction of it, x over 360. Okay, so I don't have to know the name of it. I just have to know I'm finding circumference, which is 2 pi r. I'm doing a fraction of it, x over 360. Who cares what the name of it is if you don't remember? That's called the arc length formula. Okay, but now what I have to find is I have to find this degree right here. Whatever those degrees are, that's where my x is. And this is where kids struggled. Trying to figure this out. How many degrees are in a circle? What do you know? 360 degrees is why it's 360 right there. How many numbers are on the clock? Aren't they all, first off, aren't 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, aren't they all evenly spaced? The answer is yes. So I'm doing 360 divided by 12, which equals 30 degrees. So from one number to the next, it's 30 degrees. How many numbers? There's 1, 2, 3, 4. I'm going. 4 times 30 is 120 degrees. So there's 120 degrees right there, times 2 pi r. So first off, 120 over 360, that reduces down to 1/3, 2 pi, and they told me r, they didn't tell me r, they told me d was 10, so r is 5. Okay, and therefore I get 10 pi over 3, and they tell me right here, let me circle that in case you didn't see me circle it, I put it in blue, inches. So arc length is, just got the one variable there with a degree of 1, so it's inches, not inches squared. And there's my exact answer. If it asks for an approximate answer, then I put pi in the calculator and give me a decimal. Okay, so that was one that major kids struggled with big time, even A students. Okay, that covers, I believe, everything with circles. Okay, that you need to know, or at least all the major pieces big time. I might have forgot one little thing. Okay, on circles. So I'm going to stop right there. It's an hour 21 minutes, or almost hour 22 minutes. Then I will do mods 4 and 3 next.